You can run a perfect method on a perfect sample and still miss the compound you're looking for. Not because the chromatography failed, not because the sample prep was wrong, but because you chose the wrong detector. When you're testing for trace nitrosamines, that one decision can make the difference between a clear answer and a peak that never appears. Here is the situation every lab is in. Nitrosamines like NDMA, NDEA, and NDELA, they're heavily regulated across a range of industries, from pharmaceuticals to cosmetics to food. Now, the limitations are tiny, down in the low parts per billion. And you're not looking for these compounds in clean water. You're looking for them inside a messy, crowded sample. A pharmaceutical tablet, a cosmetic cream, a rubber extract, a sausage. So you have two ways to fail. Your detector is not sensitive enough to see the compound at the limit you need, or it responds to so much of the sample that your nitrosamine peak disappears into the noise. In trace nitrosamine analysis, sensitivity matters, but so does selectivity. And the detector you choose decides which of those two problems you have, or whether you have them at all. For trace nitrosamine analysis, there are three different detectors worth looking at: GCMS, NPD, and the thermal energy analyzer, or the TEA. But let's look at GCMS first. This identifies compounds using their mass spectrum. If you already know what you're looking for and you need confidence that you found it, GCMS is one of the most powerful tools available. But here's the challenge. GCMS responds to a huge range of compounds. So in a complex sample, you're often relying on separation, data processing, and method optimization to distinguish nitrosamines from everything else present. This can be particularly challenging in the pharmaceutical analysis, where compounds involved in the formation of nitrosamines may produce similar ions and increase the risk of a false positive. Also, many methods use selected ion monitoring mode to improve the sensitivity and the selectivity. Now, in selective ion monitoring mode, you're only looking for the ions you've told the instrument to look for. That's excellent for targeted analysis, but it also means you're focused on nitrosamines you already expect to be there, and you won't see the ones you aren't expecting. Then we have NPD, or the nitrogen phosphorus detector. Now this is more selective than detectors such as FID, because it narrows down to nitrogen and phosphorus compounds. This is better, but still not very specific. It still responds to any nitrogen containing compound in your sample. In other words, it's selective for nitrogen, but not nitrosamines. And then there's the TEA. And the TEA works a little bit differently. Unlike mass spec, it is not trying to characterize the whole molecule. Instead, it selectively detects one specific feature, the nitroso group, the N-NO bond that defines a nitrosamine. Break that bond, release nitric acid, detect it. Compounds without a nitroso group do not generate the same response. And this is the whole point. Selectivity gives you a clean chromatogram. You are not hunting for a tiny peak under a pile of unrelated ones. The peak you care about is just there, on its own. So which one do you actually pick? Well, you start with the question you're trying to answer. If your goal is confirming the identity of a nitrosamine, GCMS is difficult to beat. It provides the information needed to distinguish one compound from another and verify what you found. NPD sits somewhere in the middle. It provides additional selectivity by focusing on nitrogen-containing compounds, and this can help reduce the background noise compared with more general detectors. But the limitation is that nitrosamines are not the only nitrogen-containing compounds in most samples. And once you know what you're looking for, the challenge often shifts from identification to detection. You need to find trace levels of that compound in a complex sample matrix. And this is where a nitrosamine-specific detector, such as the TEA, comes into play. And it is for that reason that many labs use both GCMS and GCTEA. GCMS provides the identification and the confirmation, while GCTEA provides the selectivity needed for routine nitrosamine analysis and screening. They're not really competing tools. They're solving different parts of the same problem. The important thing is that there isn't a single best detector for nitrosamine analysis. The right detector depends on what you're trying to achieve, the samples you're working with, and the limits you need to reach. Understanding the strengths and limitations of each detector is the first step towards building a method that works. Thanks for watching.